Hello viewers, hello everyone. In the last class, we tried to understand the topic called human eye and the colorful world, some of the topics. In this class, we'll try to understand important topic in the human eye and the colorful world, that is dispersion of light or refraction of light through the glass prism. In the last class, we understood in case of glass lab, suppose we take in a glass lab, when you pass the light, right? So it will going to pass straight, it won't go to deviate, it will going to pass straight in case of glass lab. So lateral shift we occur, no? That lateral shift formulas we understand. Incident ray, refracted ray, and emergent ray coming out. How much is the lateral shift, the derivation, everything we learn in case of plain glass lab. Now, instead of glass lab means it's a uniform field from top to bottom. So all the thickness is same everywhere. Here you can see at the here thickness and here down it is a different. So area is a different. In case of prism, what will happen when you pass the light? Okay, when you pass the light through the prisms, so it will going to deviate or it will going to shine. That we are going to understand in this video. Clear, children? So see in the figure you can see when white light you are passing, you are going to get a different colors. So why you are going to get all these different colors? What is the reason? Okay, all these things we are going to understand through this video. Okay, keep watching. Okay, children. See, try to understand when you pass white light. Okay, when you pass white light through the prism. Okay, when you pass white light through the prism, what will happen? It will going to scatter. Okay, what will happen? It will going to refract first because it is an air medium, right? It is an air medium, act like a rarer medium. When light coming from rarer medium to glass is nothing but what? Glass is a denser medium. When it is coming to rarer medium to denser medium, suppose imagine this is a normal. So when it is coming from rarer to denser, what will happen, children? It will move towards the normal like this. It will move towards the normal. So this is a normal, right? It will not away, it will move towards because it is coming from rarer to denser. That means from low traffic to high traffic it is coming. So speed going to decrease, so it will move towards the normal. So this is what we call angle of incidence I, and this is what we call angle of refraction R. Similarly, when the ray is coming from now denser medium to the rarer medium will come. So when it is from high traffic to low traffic, what happened? Your speed going to increase. Let us imagine this is normal to this second surface, second phase. Let us take ABC to the phase AC. This is the act like a normal. Let us take normal one. This is the normal two. So what happened? It will move away from the normal. Okay, like this it will move. That is why totally you can take what will happen when the ray is coming like this is the incident ray, refracted ray, and the emergent ray. Okay, emergent ray is what it is bends towards the base of the prism. Okay, it is bends towards the base of the prism. Suppose you will take the prism like this. Okay, inverted form. What will happen? When you pass light ray, it will again going to refract and it will move towards the base of the prism. It will refract because rarer to denser, and again from denser to rarer, it will move away from the normal. It will move. Okay, this is what the process will take place. Now let us learn what are the angles included here. The angle of incidence, what we call this is from normal to the incident ray, we call angle of incidence I. This is angle of incidence normal to the incident ray, and normal, this is normal, right? From normal to the refracted ray is called angle of refraction R, and from normal, second normal to the extended or emergent ray, what we call angle of emergence E. Okay, these are the few terminals. This is R1 and this is, we can take it as a R2. R2 is nothing but incident ray. Okay, incident angle, what we call I2. Okay, incident angle for this mirror. We can take this as a R2 also or emerging angle also. Okay, these are the terminologies what we going to derive the relation for dispersion of the white light through the prism. Or to explain in the CBSE board, they given one activity. Okay, to understand this, they taken one prism. Okay, let us take one prism. Okay, placed on white sheet. Okay, one prism you're going to place on white sheet and pass the light. Okay, let us take the laser light. Okay, laser light you're going to take and pass the light. What will happen? It will go like this and it will come back. Now, the path of the light you're going to trace. Okay, put two pins here, one pin here and one more pin, and two paper pins or cardboard pins we're going to put like this. Because a path of light we cannot put the scale and light. When you put in scale and light, it will be, our hand will be obstructing the light ray. So that what we do, just put the path of light, you just put the two pins out this side and two pins this side, and you just draw the one line for prism is there here to here. Now you remove this prism. So how it is looking like two lines, and this side also two lines. Now you're going to take the scale and join these 2 points. Okay, when you take the scale, okay, join this point, this 2 points you join and just perpendicular, and again two lines you just join. Now you can write this is normal to the surface perpendicular, this is normal, you can draw before only. So now you can measure the angle of incidence I, angle of refraction R1, and here angle of incidence for the second medium, that is we can take R2, and angle of emergence is E. Okay, like this is going to take the readings. Okay, and you can draw, just you draw the prism also. Okay, this is what experiment. Your experiment shows that what dispersion produced by the prism. Okay, how the refraction takes place through the prism we are going to observe. If it is one color, it will be taking place like this. Suppose you know that white color. Okay, what is the white light, sunlight? No, the sunlight is made up of 7 colors. So all color they're going to refract as well as they're going to disperse. Okay, why they're going to disperse, we're going to understand in the next videos. Yes. Okay. See, now try to understand the derivation for variation of deviation with the angle of incidence. When you try to increasing the angle of incidence, okay, before that you need to understand what I'm saying. Here you try to understand first. Refraction of the light through the prism. How the light will going to refract when it pass through the prism. So this is a prism actually look like, actually in the 3-dimensional figure it is actually, when you try to draw in the 2-dimensional, it is look like a triangle. Okay, 3-dimensional just look like a triangle, you're going to imagine that one. So when you pass, okay, children, see what you are doing. When you pass the incident ray, this is what we call incident ray, through like this, what will happen, instead of going this path, if there is no prism, it will go like this. Because of the prism, how much it will deviated, it will come in this path, it will refract all through this, and it will going to emerge, and it will go like this. So see, if there is no prism, the path will be like this. If because of prism, the path will be, because it will be coming this way. So this from here to here, the ray is deviated. Okay, from here to here, the ray is deviated because of the prism. So that is what we call angle of deviation delta. Okay, angle of deviation delta, because of the prism it is deviated. So that is what we are going to calculate. Okay, that is in the refraction through the prism it will happen. We need to calculate angle of deviation. And what is the relation between the incident ray, incident angle, refracting angle, and the emerging angle. So let us turn to learn this one. Let us imagine first a quadrilateral. You are observing here, no? A, P, and Q. Okay, A, P, O, Q. This is a quadrilateral. So looking like this, so A, P, here is a O, and here is a Q. A, P, O, Q. You understand this quadrilateral? Here angle I and angle O is equals to 180 degree. Okay, because this is suppose it look like a base, no? So we can observe here angle A and angle O, they are like some of the angles will 180 degree, because since N1 and N2 are the normals. Here what is that, N1 and N2 are the two normals, they are perpendicular to the surface, right? So that is what we can take, I plus A plus O is equals to 180 degree. This is, let us take equation 1. Similarly, you can observe in a triangle OPQ. In the triangle O, okay, this is a triangle OPQ. This is a triangle that telling. Okay, in this triangle, okay, what is the values are there in this triangle? Let's just write down. This is what, children? This is R1. This is R1, and this side is, you can observe, it is R2. And here what is angle is there? Here angle O is there. So sum of the 3 angles of a triangle is 180 degree, right? So that is the second line, right? And in a triangle DPQ, in a triangle DPQ, you can observe the top one here, D is there, and here P is there, Q, this triangle. Okay, in a triangle DPQ, D is there. Okay, in a triangle DPQ, what they given? Delta, angle delta This is exterior angle. Okay, let us learn right properly. Okay, this line is there and here is a triangle. Okay, this is angle, here D is there, here P is there, and here Q is there. Okay, PQR, and here delta is there. This outer angle is a delta. Now you want exterior angle. So what is the exterior angle formula, children? Sum of the two opposite interior angles, right? This angle and this angle. So this down angle, you can observe total is 90 degree, and that is P equals to I. If total is I, one is R, so remaining portions we can write I minus R, right? Similarly, this side also I minus R2 we can write. So this angle is I minus R1 and this angle is I minus R2. R we can write it is E this side, no? So we can write it instead of I, E minus R2. These are the two angles. Now we can observe this exterior angle is equals to sum of this and sum of this. Interior opposite angle. This is the interior opposite angle. So we can write delta is equals to I minus R1 plus E minus of R2. So you can take I at one side and R1, R2 at the one side. So I and E are the positive we taken, and R1, R2 is negative is there, we take a negative common, so R1 plus R2 will happen. So now we observe equation 1, 2, 3. So we can solve this equation 1, 2, 3, but you will get from 1 and 2, this and this equation. See, in place of 180 degree, left hand side equal. So right hand side O is also equal, it will cancel. So only left is what? A and R1, R2. From this angle A is equals to this angle is equals to sum of this and this angles. Okay, R1 plus R2. And from 3, what you will get here in place of R1 and R2, just to replace with A. So what you will get? I plus E is equals to A. Now rearrange this A plus I. Okay, A plus E is equals to, send this A to left hand side, it will become A plus delta. So this is what angle of deviation we're going to find. The deviation is equals to, okay, I plus incident angle, emergent angle minus the angle of the prism. They will give angle of the prism is how much, and incidentally how much we are incidenting, emergent angle we can find. Okay, from that we're going to find angle of deviation. Okay, this is the derivation, children. Yeah. After the derivation, try to understand what the derivation is, the dispersion of white light through the prism. When you pass only one light, okay, that was observed in the last slide. When you pass only one light, well, like laser having only one light, red color and green color. When you pass this one, it is going to deviate. That is what we observe, and we derive the relation for angle of deviation. But here we are passing white light. White light is a combination of 7 colors. It is not a single color like laser beam. White light will be consisting of 7 colors. That means all the 7 colors does not have or does not possess same angle of deviation. Clear, children? It does not have same angle of deviation. Instead of white light will go in this path, all the different wavelength, because each color will have different wavelength. All 7 colors. Suppose we have see blue color, it is around 456 nanometer. That is the blue wavelength of blue. And you can take a red light, it is around 665 nanometers, like that. So you can observe blue to red color, they have a lot of difference in the wavelength because of change in wavelength. See, what is wavelength means? It will go slow and it will go fast because of this. So this violet will have more wavelength. So more wavelength will, violet will have less wavelength. Okay, it will have less lambda. That is why it will reaches here faster and it will come out. But red will take more time to come out from here to here, and it is coming red. Okay, so which will deviate more here? Violet will be deviate more and red will be deviate less. Okay, based on this wavelength. Wavelength of this is less and wavelength of the this red color is more, because that is why it is deviation is less. So we will observe what is the dispersion means. The phenomenon of a splitting of white light into its constituent colors. A constituent colors, what we call as a the 7 Webb colors, and wave constituent colors. Wavelength is wavelength, different wavelength they have. Is called as dispersion, and the band of colors, what you will get now here, the band of colors. Suppose you put the screen here, in the screen you will get different colors, one color, second, third color, fourth, like that. So starting from where V to R. So Webb band you will get. That is what we call spectrum. Okay, the spectrum is the band of colors from violet to red. That is what we call spectrum. The spectrum will be in the order of Webb. Okay, remember this word: V, violet, indigo, blue, green, orange, red, Okay, like this a bit colors indicate. Okay, here yellow is there, yellow you can see. Okay, so what is a dispersion of light? You understood why it will going to disperse instead of one ray, it will come so many spectrum you will get. That is because of dispersion of light. White light composed of 7 colors, so that all the 7 colors going to split because of change in wavelength. Because of the change in wavelength of all the colors, they're going to deviate like this. Okay, one will come faster, one will come slower. Because of that, which will come faster, they will deviate more. Which will come slow, they will deviate less, like that. Okay, this is what the dispersion phenomena. What is this? Is what the meaning of dispersion. So causes of the dispersion, that is what refractive index. Okay, what is the refractive index of the glass? 1.5. Okay, this based on the refractive index, the dispersion also depend. Okay, so that is given by sin I by sin r, where I is this angle of incidence, and r you can see for violet color, refractive index of violet. Okay, how much violet is raining r, and refractive index of, suppose it's a violet color only. For red color you want to take sin I by sin r. Sin I means this is only, I is the incident angle, but the red color you can see the refractive angle is this much. Okay, this is what we call sin r. So this is what, where refractive index of violet is more and compared to refractive index of red, and so that red will have more refract compared to the violet color. Okay, so the colors are refracted at a different angles, and hence we get the hence they are separated. Okay, we can able to separate all the colors through the prism when you pass light through the prism. This is what we call dispersion of light. I think this is clear, children. Okay, so try to understand what is a dispersive power. Okay, dispersive power means the material of a prism for any two colors is defined as the ratio of angular dispersion of those two colors. Okay, this is what we call a dispersive power given by omega, that is pi by delta. Okay, with these terms are little new, no need to worry about it. Try to understand. Highest, let us take dispersion of violet minus of dispersion of red divided by total dispersion. That is what we call mean deviation. Or violet, which is highest coming down with Gaia, with Gaia. Least is red. So the difference of these two will take, that you will get the dispersive power. How much it will going to disperse, that will be depending upon average dispersive angle of the both. We're going to take average and we're going to obtain this formula. You will get the dispersive power of the prism. Okay, so that is for reasons, because of the dispersion only you're going to observe so many phenomena in the nature, interesting phenomena in the nature. That is blue color. Okay, the sky appears blue color in case of the afternoon, and it is reddish appearance in case of the evenings and the morning. Okay, before sunset and sunrises, it will appears reddish. So the reasons for this is also explained using the scattering phenomena. So you know violet the blue color and violet color having the less lambda, that is less wavelength. That is why they're going to, when it enters the atmosphere, they're going to split there only blue color. Only the whichever having more wavelength, that will reaches down. That is why in the afternoon time the distance between us and the sun is less. It will be at the zenith, right children? Earth. Okay, when we are, the sun is at nearby head, so that time only we see the blue color or violet color, because less distance the blue will be scattered. When the sun is at a far distance, that means in the equator, that time you can see evening times, you can see the sun is at a far distance, the blue will scatter, but what is reaches us, red color will be reaches up to the far distance, so that we can see a red color in the evening times. Clear children? Why in the blue in the afternoon? Why sky appears blue? The sky is not a blue color, but it appears blue because of the scattering of the small particles in the atmosphere. That is why in case of night times we cannot see the blue color of the sky, because there is no light is there to disperse in the night time. And you can see out of atmosphere you will go also, out of atmosphere also you can see the black color only. That is also because of this, there is no particles to disperse the light. That is why there is no refraction or blue color of the sky if you go outside the atmosphere. Okay, I hope this is clear to you all. Thanks for watching, children. Keep watching. In the next video, we'll try to understand how the rainbows will form out twinkling of the stars. Okay, atmosphere refraction we're going to understand. Thanks for watching.